Question 1 of the assignment review is on statistics. So when you're given information which is in what we call ungrouped data like this, you need to use a suitable class width. So to determine a suitable number of classes to have, you need to know the formula to use. Firstly, we need to identify the total number of observations that are in here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So here we have 6, and here we have 7. The total number of variables n is equal to 42. All right, so to identify the suitable number of classes, we also identify the highest number and the lowest number to get the range. So identify the smallest number, we have 22. The highest number, we have 87. So how do we get to finding appropriate classes? We divide the range divided by our class number of classes, or k, our class width. Now, to find our k, we need to find what can power the 2 to get what? A number that is greater than n. So the formula that we use is 2 to the power k should be greater or equal to n. So if you have numbers from 0, 1, 2, 3, 4, 5, 6, 7, if you like. So 2 to the power 0, what do we get? We get a 1. 2 to the power 1, get a 2. 2 to the power 2, we get a 4. 2 to the power 3, we get 8. 2 to the power 4, we get 16. 2 to the power 5, we get 32. 2 to the power 6, we get 64. So these numbers that we are looking at here represent k. So to find the number that first exceeds our n, which in this case is 42, we need to check here. So this one does not exceed 42. This one is not more than 42. This one is not more than 42. This one is not more than 40. This one is not more than 40. This one is not more than 42. This number is more than 42. So the k that we're going to consider is 6. So our range is simply the difference between the highest number and the smallest number. Or in this case, our highest number was what? Was 87. And our smallest number was what? 22. And our k in this case we found as 6. So when you divide this, we get 10.87, which approximately is equal to 11. So 11 will be our class width for this question that we're considering. So that being the case, 2 to the power 6 is 64, and 64 is more than 42. So this is what we are looking at. 11's class width. So class width is start with the smallest number, 22. We add the 11. 22 plus 11 is 33. We add 11. 44. We add 11. 55. We add 11. 56 and 77. Then this side we just add -1. Since we're not including the numbers, we just add a 10. Here we're adding 11. So 22 plus 10, 32. 33 plus 10, 43. 44 plus 10, 54. So we now manually need to go to our data set in here. Look for the numbers between 22 and 32. So 22 we have 1, 22 and 32. We go here 2. 22 and 32. So here 1, 2, 3, 4. So we only have 4 in the frequency. Between 33 and 43, you do the same, you find 4. Between 44 and 54, you find 9. Between 55 and 65, you find 14. Between 66 and 76, we find 6. And between 77 and 87, we find 5 figures that are within that range. Then we total up. These are coming to 42. The relative frequency, 4 out of 42, is 2 over 4 out of 42. You can leave them in decimal points. 9 out of 42, 14 out of 42, 6 out of 42, 5 out of 42. Then you accumulate them. The 4, you bring it here. 4 plus 4, 8. 8 plus 9, 17. 17 plus 14, 31. 31 plus 6, 37. 37 plus 5 is 42. So these ones are cumulative frequency. Again, we divide them over the 42. So 42 over 42, 37 over 42, 31 over 42, 17 over 42, 8 over 42, and 4 out of 42. So this is what we call the relative cumulative frequency. This is called the relative frequency. So this is what we call the frequency distribution table. This is what we call the frequency distribution table. So you're at liberty to leave it here, or just these 3 columns, 1, 2, and 3. They make up what we call the relative or the cumulative frequency table. So basically, this is where the 6 marks was supposed to be gotten by just identifying the suitable number of classes. That's where the text was. All right, then we go to the second question. In this question, we're being asked to construct a stem and leaf diagram. Stem and leaf diagram.
Collins.
Yes, please.
Are you going to share the video?
Sure, I will.
Okay. Because I'm just a bit tied up. I think I'll rely on the video when you share.
So in this case, we're going to. Are there any questions before I proceed? It's clear. Let me go. I'll look at this one later on. Let's go to part C. So part C, we're given an examination which was held to decide awarding scholarships by 3 candidates out of 100. So the weight here we have here is 4, 3, 2, 1. The total we're getting here is 10. So 10 into 4, we get 0.4. Percentage, 10 into 3, we get 0.3. 10 into 2, we get 0.2. And 10 into 1 is 0.1. We're being asked to calculate the mean award to the scholarship. So we're going to apportion these percentages to each. So we'll start with student A. Student A, what do they get? 0.4 times what? 60 plus 0.3 times what? 62 plus 0.2 times 55 plus 0.1 times 67. Then you evaluate this to find our mean weight. So you do the same for the others. So you're going to have student A is going to get 60.3. Student B is going to get 59.4. And student C is going to get 61.6. So this is after finding the proportions of each in terms of proportions. So 4 divided by 10, 0.4. 3 divided by 10, 0.3. 2 divided by 10, 0.2. And 1 divided by 10. So yeah, in fact, multiplying each of these ones with the respective figures there and summing up. And also, you multiply for student B, you multiply for student C, and this is exactly what is happening at each and every point here. So the mean weight for each student is as calculated. Are we together? Is that clear? So this is what question number part C was asking for. All right, so we go to question part D. We are told that management has a consulting firm. It has 4 types of professionals in its staff. We have what we call managing consultants, the senior associates, the field, the office staff, and they charge in categories. So respectively, the managing consultant, they charge $150 per hour. The senior associates, $16.80 per hour. The office, the field staff, $12.60, and the office staff, $6.30. So we are also told that the hourly charges are as follows, respectively. So senior, the managing consultants, they take in a year 8,000 hours. Then the field staff, 14,000. Field staff, 24,000, and the office staff, 35,000, respectively. Now, this firm wants to come up with a uniform billing rate. So firstly, we want to calculate what would you suggest is what we suggest they do and what is appropriate. So we need to find the mean billing rate. Okay, so we are going to construct a table that will summarize our story here. So we have the managing consultants with 150 taking 8,000 hours. So we multiply these two, costs for the managing consultants about 25 million. Senior consultants take 1,650 for about 14,000 hours, and the total they spend is 23 million expectation. Field staff 1,260 and take 24,000, and the total expectation is what? 30,000. And office staff 630 and take 35,000, and the expectation is 22,000. So to find the mean, the total expectation is 101 million, and the total number of hours is 81 million. So to find the average, we're going to divide the sum of the revenues over the hours. So when we total up here, you can see we are finding our rate in average as follows. So that is the average that is being taken in terms of time, the hourly rate. So we can simply say when you divide 101,010,000 over 81,000, we're going to get 1,247.04 per hour per employee. So this means that is the average that should be charged as uniform as can be. Any questions so far? So that is the average charge. So we just found it by simply multiplying the rates that are being charged by each type of consultant, and later on calculating it with the average time in terms of the hours, then computing the total number of hours that are there, we're getting 101 million, and we're dividing by the total number of hours there. So this will give us the average charge that will be 1,247.04 per hour per employee. So ideally, that is the price that should be charged uniformly to avoid this exploitation that we are seeing here. That is the average charge that should be considered. So it can be suggested that the company only charges a uniform figure of 1,247.034 across consultants without varying consultation fees for all the 4, because this amount will still give you the same amount of revenue. Of course, what can we advise them? In reality, when you're going to a hospital, if they are given an option to be seen by a doctor or a clinical officer or a nurse, you'd want to get the most qualified there. So the question is, why should you unify them with the different expertise? So the other measure that be taken is that the quality of the consultation must be the same throughout. So that is a submission could give, because the question had, what do you think is appropriate? All right. Part E, we are told that you're working for a transport center which has cars for staff, and you're interested in weekly distances. So we're given the following information. So between 100 and 110, we have 4. Between 110 and 120, we have 0. 120. So these are the frequencies. So we can call this our value of X, and we can call this our frequency. So we can come up with a cumulative frequency by adding on. So 4, we bring it here. 4 plus 0 is still what? 4. 4 plus 3 is 7. 7 plus 7 is 14. 14 plus 11 is what? 25. And 5 plus 8 is what? 33. 33 plus 5 is 38. 38 plus 0 still remains 38. And 38 plus 2 is 40. So this is our cumulative frequency, and this is our frequency. So the question is asking us to come up with the cumulative frequency distribution and to draw a or give for the cumulative frequency. So you can use any bounds, the lower bound or the upper bound, to match this. So once we get this in the cumulative frequency, so we can say 100 against what? 4. 110 against 4. 120 against 7. 130 against 14. 140 against 25. 150 against 33. So this is the max. It's a straight line and keeps going. There's another straight line and it keeps going. So this is what we call our cumulative frequency or give. It's a line that joins the points that you can see as follows. All right. That being said, the question further asks for us to estimate graphically the number of cars that are covered in less than 165 kilometers in a week. So on the graphing, first of all, before I proceed, are there any questions? Is there anyone behind so far? Are we together? Ronnie, are we together?
Yes, it's clear.
Very clear. Okay. So if we're moving together, then like I said, preferably for this particular question, I would have loved that you use a graph paper to illustrate so that you get the most accurate figures from there. Okay, so we're being asked now to graphically estimate the number of cars that will be covered in less than 165 kilometers in a week. So you go to 165, which is somewhere here. Then you draw your line. Then you take it there. So the question is asking us to find what? Number of cars that would be less than 165 kilometers per week. So when you go to do the estimation there, so less than 165, how many number of cars? Was that figures that it's giving us 38 here graphically, because the question is asking estimate graphically. So others will find different answers. but within a certain range. So if you're going to use this one here, less than 165 is somewhere. 165 is somewhere in between here. So we're looking at these figures there. So we can add 4 plus 0 plus. So approximately it's 38. Right? So now the answer should not be the same or exact. So if you go here, others will find 37, but it must resonate with what we are looking at. So 38 using graphically, but it can also be shown less than 65. 38 is what we're getting. So you can see the graph there is starting to 38, where 38 is. Are we together? That is a case in there. So use a graph paper to be accurate with your estimates. Right, so calculate the Q1, Q2, and Q3. So to find the quartiles, are 40. So Q1 is what? A quarter of n. Q2 is half of n. Q3 is 3/4 of n. So our n in this case is 40. So a quarter of 40 is 10. Half of 40 is what? 20. 3/4 of 40 is what? 30. So 10, 20, 30. So when you go here, Q1 is 10, you get the approximate here. Q2 is 20, you get the approximate there. And Q3 is 30, you get the approximate there. So these are the figures that we have approximately. So when you go here, our position of the 10th is coming to 125 kilometers, which we can see somewhere there. Our Q2 is coming to 100 and what? And 40 kilometers, and our Q3 from this approximation is coming to 150 kilometers. So these are the corresponding quartiles using the graph. Right. Then we go to the next question now. Question number 2. From a computer tally, the manager of a large manufacturing firm finds 15% of the firm's employers are supervisors, 25% are college graduates, and 5% are both college graduates and supervisors. So suppose a random selection was done from the firm's records from the probability that a person has both is both a college graduate and a supervisor. This one is mentioned here, so we can come up with a key. We can let A be what? A be supervisor. Supervisors. And let B be what? College graduates. So in this case, we let A be employee supervisors, B be college graduates. So in our question, we're told that 15% are what? Are supervisors, which is 0.5. We're told that 25% are what? College graduates, which is 0.25. Then A intersection B is 5%, which was for both college graduates and supervisors. So here we have A, which is 15%, B, which is 25%, and 5% or 0.05 is both. So what is the probability of having both? So this one is already there, A intersection B, for having both college supervisors and graduates is 5%. So that is the intersection we are talking about. Then part B is asking us to find what? The probability that a person is neither a supervisor or college graduate. Neither. So in this case, we need to understand a few axioms. Okay. So in this case, we must understand that the probability for axioms is given by probability of A union B is equal to probability of A plus probability of B minus intersection. So to unite is to add. To intersect is to multiply or find something common. So the question is asking us to find the probability that they are neither. Neither means complement. So they want to find the probability that this one is not what? A supervisor? No. Are they what? Are they college graduates? So the only way to finding this is we subtract from 1 the union set where all of them are found, A union B. So we know that the probability of A in this question was what? College supervisors. Probability of A was what? 15%. Probability of B was 25%, and the intersection was 5%. So supervisors A, 15%. College graduates, 25%. Then we remove the intersection, which is from both college. So we're going to get that 5%. To find probability that we have neither college supervisors and graduates, so we're going to subtract 1 minus that 5%. So if the 5% are both supervisors and college graduates, then meaning the remainder, which is 65%, is neither of the two. So in essence, this is what we are doing. So A complement intersection B complement is 1 minus a union of the two. So our union set, A is 15%, B is 25%. You remove the intersection, which is 5%, to get that 5%. So ideally, you're seeing that A is 15. So this total here is talking about those ones that are supervisors and college graduates, which is that 5%. So meaning outside this is the complement of 65%. So this is where we get the 0.65. All right. So this is how we get our 2 marks from there. Then question number 2, part B. I'll explain briefly on this so that you appreciate the concept. So if you're given probabilities A, B, X, Y, and you have 2, 4, 6, 8. So the first thing is to get the totals. What's the total for A? You add up, get 6. Total here, 14. And total for B, 8. Total here we have what? 12. And the sample space is 20. This is total for everything. So to find the total for A, you get the total for A, which is 6 out of the sample space. So 6 over 20, which is 0.3. If you want to find for B, you get the total for B. You go where the B is and you get its total. What's the total for B? 8. So 8 out of the sample space, 20, 0.4. If you want to find the probability of X, you identify where the X is, 14 out of the total, 20, 0.7. If you want to find the Y, you go where the Y is 12 out of the 20, just get 0.6. So in like manner, A intersection B, you go where they meet A and B, they meet at 2. 2 out of the 20, which is 0.1. But if you're finding A given B, you still go where they meet A and B by drawing a plus here. They meet at 2. But the total for the bottom guy, the total for B is what? 8. Is 0.4. How about if you want to find B given A? They still meet where? At 2. But the total for A, in this case, they are meeting at 2. But A, the total for A is what? 6, which is 0.33. So these ones collectively will help us find the union set. What is the union set for A and B? The union set is probability of A plus probability of B minus the intersection. That's the formula. So our probability of A is 0.3, our probability of B is 0.4, the intersection of A and B is 0.1. The final answer here, we're going to get 0.6. Okay, let's do the same for the values of X. So how do you find the probability of X intersection Y? So you draw a plus where X and Y meet, it's at 8. When you're dealing with an intersection, you always get the grand total. 8 over 20 is 0.4. Okay, but to find probability of X given Y, or the probability of Y given X, you still go where they are meeting, they're both still meeting at 8. But the key thing here is the total for what? So if it's X given Y, they're meeting at 8, but the total for Y, in this case, which is down there, Y is what? 12. If you have Y given X, they're still meeting at 8, but the total for X in this case, which is 14. Therefore, to find the union set X union Y, we're simply going to say probability of X plus probability of Y minus the intersection of X intersection Y. The probability of X, we had found what? 14 over 20. Probability of Y, we had found what? 4 over 20. And the intersection, we had found 8 over 20. So this will give us our final answer, which is 18 over 20, or 0.9. Now, there are two rules that you also need to understand, rules of independence or mutual exclusive. So mutual exclusive means you have nothing in common. So if events A and B are mutually exclusive, it means their intersection A, intersection B is equal to 0. For independence, if you want to know whether two events are independent, the probability of A times the probability of B must be equal to the intersection. Chapel. Now, there are only three steps, in fact, that you need to do. Number one, you need to state the condition of the step. Number two, you need to compare the figures. Number three, you need to conclude. So let's see whether A and B are mutually exclusive. What is the condition? A intersection B must be equal to 0. Number two, you compare. What was our A intersection B? In this case, A intersection B was 0.1. So is 0.1 equal to 0? No. So what is the conclusion? Not what? Mutually exclusive. How about independence? The condition for independence should be, so this is for mutually exclusive, or mutuality, or independence. What is the condition for independence? A intersection B must be equal to what? Multiplying A times B. So what was our A? You go back to what was given. Our A was what? 0.3, our B was 0.4, and our intersection was 0.1. When you multiply these two, it should give you 0.1. So 0.1 is the same as 0.3 times 0.4. You compare them. So we're getting 0.12. Are they the same? No. So we conclude that they're not what? Independent. So this is the same procedure that we're going to use to identify the relationship. We'll go back to our question here. So the first thing we do is to get the totals. We can call this male, letter M, female, letter F. We can call this shopped S, and this is never shopped N. So we're going to total up. So what's the total here? 800. What's the total here? 1, 2. What's the total here? 1, 2. What's the total here? 800. What's the total of totals? 2000. So what's the probability that they never shopped on the internet? What are they asking for? Probability of what? N. Who wants to tell us what's the probability of N? The total for N, 1200 over the total of totals, 2000, give you 0.6. So probability that they're female. They're asking us that they're male, the total for M. So M here is also 1200 over 2000. So we're going to get 0.6. Here, what's the probability that they shopped on the internet given that they're female? So they're actually asking us to find probability of what? Shop given F. Let's see where they're meeting F and shopped. It's 300. But the total for what? The bottom guy, F. F is what? 800. So 300 over 800 can evaluate. Even here, it's probably that it is male given they shopped on the internet. So here, they are asking us to calculate what? Probability that the first one was what? Who wants to try to give me the notation? What is the notation? Probability that the person is probability that the person is what? Male, given that they shopped on the internet. What's the notation there? Anyone? Are you getting me?
Yes.
Okay. Can you try to give the notation?
Yeah.
Okay. In the interest of time, so we are looking at those conditions. So probability okay, so we found the probability that never shopped 0.6, probability that the male 0.6. About shop given female 300 over 800, which is 0.35. Here they're asking for male given they shopped this 0.625. So this is what you're supposed to do. Now, part B is interesting because it's asking us to find whether the events male and female are mutually exclusive. So if you're going to see the diagram there, you have male and female on one side. Okay, they don't meet anywhere. They're all parallel in the same line. So probability of male intersection female is equal to empty set or 0. So we can conclude that these two events are what? Events are mutually exclusive. I was even asking you to explain why you can't be a male and a female at the same time. So it is also impossible in real sense that these two can be the same. So mutual exclusiveness is also being exemplified there. So in part B, we know that for them to be mutually exclusive, they have nothing in common. For them to be independent, A given B must be equal to the intersection. So in reality, M intersection F is equal to 0, hence events M and F are what? Mutually exclusive. So I further on explained at length regarding that issue to say, for a female and male to be mutually exclusive, the intersection female intersection male must go to 0, point number 1. Now, since our M intersection F is equal to 0, we can conclude that events are indeed mutually exclusive. In reality, one cannot be male as well as female at the same time. So for independence, we're being asked, are the events male and shopped independent? Why? And if not, so we want to explain. So in this case, male and shopped, when we multiply them, they should give us an intersection. So what's the probability of male? We get the total of males here. 1,200 over 2,000, 0.6. The total for shopped, we go to the total for shopped, it is 800 over what? 2,000. 0.4. And where do they meet male and shopped? When we go here, the male and shopped, they're meeting at what? 800. But the total for what? Oh, male and shopped. They meet 800, but since it's intersection, the total for everything, which is 2,000, which is 0.25. So when we apply these to 0.6 and 0.4 to give us 0.25. But is it giving us that? 0.6 times 0.4 is 0.24. And the intersection is 0.25. So here we can conclude that the events male and shopped are what? Not independent. We can only say they're independent if the answer we got was the same. All right, so lastly, we're given a table that the H2 Hammer limousine has 8 tires on it. A fleet of 1,300 H2 limos was fit with a batch of tires that was mistakenly passed the test, the quality test. The following table shows the frequency distribution of the number of tires on the 1,300 H2 limos. So here I have 0 up to 8. The number of H2 limos are the frequencies. So this is random variable X and the frequency. So we can come up with a frequency distribution table using the number of tires. So what we can do is our X, the number of tires and the frequency is there. So we can total 1,300. So we'll be dividing 59 over that. We get 0.05. 224 over that is 0.17. 269. So these, in essence, are the probabilities that we're getting. So we divide each of these ones over the total, and these are the figures that we're getting. So part A of the question is asking us to denote X as the number of defective tires. So what's the probability that it will range between 3 and 7? So this means that include 3, but less than 7. We're looking at the numbers what? 3, 4, 5, 6, don't include 7. So let's find the probabilities that are between 3 and 6. So basically we're adding the probabilities, these ones here, 3 and 6, these ones, when we add them up. So between 3 and less than 7, so 3 and 6, we're going to add them 0.27, 0.16, we're going to get 50% or 0.5. Then the last part, the numbers variables of x greater than 2. So greater than 2 means starting from 3, 4, 5, 6, 7, 8. So greater than 2. We're looking at these figures from here up to there. Now, funny enough, these two are very insignificant. They're giving us 0.000 something. So when we add these figures there, we have a bit of what? 2, 3, 4, 5. Alternatively, you could have just said 1 minus these ones that are not wanted. 0, 1, 2, 3. You subtract 1 minus the total of these 3. Is to get the same answer. So here, 1 minus probability of 0, probability of 1, probability of 2. So when you add all these, you're going to get 50% as well. So 0.5 is the answer that we got in this instance. So this is how this paper was supposed to be answered. Unless there are any questions, please you can ask now.